talking about today, and you guys have your foldable. The first special type of angle are called adjacent angles. And those are angles that share a vertex and a side, but there's not going to be any interior parts that are shared, which basically just means they're not going to overlap each other. Okay, so there's no overlap. So if you look at your illustration, 1 and 2 are adjacent. Do you guys know what adjacent means? No? The two things are adjacent. Yeah, they're next to each other. Okay, so adjacent angles have to be next to each other. Now, as we're going through these today, I'm going to give you the definition and illustration, and then I'm going to let you have time to do those examples. So if you can get through all the examples yourself, you can go ahead and do that. You're going to notice there's a lot of repetition to make sure that we understand those pieces. So for number 1, it says name the angle adjacent to angle 3. Okay, so take a second and see if you can do that. And then also go on to number 2. And then your homework task, just make sure you put that in a safe place. A good place is like in the front of your binder. If you have the clear binder, or like zipped up in a pouch, or stapled to your planner is a great place. Okay, so Lance, what do you think? For number 1, what did you say was the adjacent angle? Okay, so what are you thinking? So it's the angle adjacent to 3, so really we just have a couple of options, right? It's either going to be 1 or 2. What are your thoughts?
1.
Okay, and tell me why you think that. It's right next to it, right? So that's right. So it is angle 1. Another way that you can remember which one it is, they have to share a side. So angle 2 does not share a side with angle 3, so there's no way it could be angle 3. All right, and then for number 2, it says name the angle adjacent to ABD. Okay, so ABD. So what I did is I just highlighted this side so that we could write out our angle. Deanna, what are you thinking for that one? Which one's next to ABD?
DBC.
Good, yep, angle DBC. And you guys could also call that CBD. Okay, so either one of those are fine. Right, for number 3, it says to name the 2 angles adjacent to angle YZW. I think some of us probably have not had time to do that yet, so I'm going to go ahead and give you another minute. Okay, so Robert, what are you thinking? What are the 2 angles that are adjacent to angle YZW?
I said VZX.
Okay, and?
I didn't get the second one.
Well, what do you think? Because adjacent means what? adjacent mean again?
Next to.
Next to, right? So if it's next to, right? If you're looking at it, VZX is going to be across from it, opposite. That's another special type of angle we're going to talk about today. But what's one that's right next to it? So if this is VZW, Robert, whoa, okay, it has to share a side, right? Does VZX share a side? No. And you're not the only one that said that, because I walked around and I saw, and I know last hour people did the same thing. So you know they don't share a side. So what I would do is I would look at this side and then pick out one of my angles from there. So Robert, tell me what they are now.
VZY.
Yep. And?
Then XZW.
Good. Okay, so VZY and then XZW. You could also call it YZV, that would be fine, or WZX. Okay, good. So the two angles adjacent, they have to share the side, okay? All right, and then our last one, it says name the angle adjacent to AFB. Now there's actually multiple answers for this one, and you can see how I highlighted that first, because I know that I'm going to have to share a side. Does AF share a side with anything? No, it's only the BF. So you could have BFC, you could have BFD, or you could have BFE. Okay, and whichever one you chose, make sure you write down the other two so you understand that there could be more than one answer for that. Okay, it could be any of those three choices. All right, and then after adjacent angles, we are going to go to linear pair. And linear pair is the very last one in your foldable. And if some of your, like, see how some of these are overlapping, if you need to, you can always, like, write that below. But linear pair is the very last one, so we are going to flip that up. And once you see the definition for the linear pair, you might understand why we decided to go there next. So again, I just want to remind you, I'm putting up the definition, and then once you guys have the definition and the illustration written down, you can start thinking about those example problems. Okay, so a linear pair is a pair of adjacent angles. So the reason why we did this next is because we just talked about adjacent angles. So a linear pair has to be angles that are next to each other. And then the non-common sides, which are just the sides that they don't share, are opposite rays. And when you have opposite rays, that makes a straight angle. You can see in my illustration, I just highlighted those two opposite rays. Now, if it's a linear pair, the sum is 180 degrees. And some of you probably already know this, but if the sum of two angles is 180, those angles are also called supplementary. And that's another special pair that we will talk about today. So in the drawing, angle 3 and angle 4 are a linear pair. Okay, so knowing that a linear pair adds up to 180, you can definitely do number 1. You probably can do all of them. But at the very least, I want you to do 1 and 2, and I'm going to give you some time to do that now. Alright, so the important thing to remember about a linear pair is that they add up to 180 degrees. So, Alex Deshevsky,
What?
for number 1, how did you figure out what the other angle was?
Oh, I did 180 minus 138.
Good, okay, so if together they make 180, you can just subtract 138 from 180, and then you should get 42. Great. Okay, for number 2, it says name all the linear pairs. So, Aubriana, a linear pair is essentially just going to make up what?
It's gonna make up the
Yeah.
measures that share a line to make the full 180 degrees.
Good, so it's just going to be 2 angles that are going to make a straight line. So, Aubriana, give me 2 that make up a line in part 2.
Part two,
Mhm.
it was 5 and 6.
Did you say 5 and 6? Yes. Okay, so 5 and 6 is going to be one of them. 5 is also going to make a linear pair with what? 7. Okay, so both of those should be on your list. 5 and 6, 5 and 7. 6 is a linear pair with 5. It's also a linear pair with 8. So 6 and 8 should be on your list. And then 8 is also a linear pair with 7. So those should be the 4 pairs that are on your list. Okay, so now if we look at 3, it says that you have 2 lines and they intersect at M. Find the measure of those 2 angles. So what we're going to do is we're going to take a look at our picture and we're going to see what type of situation that we have. Okay, so we can see from the picture that these 2 angles make up a straight line. So if the straight line is 180 degrees, I'm going to set up an equation based on the fact that the angle LMO and OMN, if I add those 2 angles together, I'm going to get 180. I know some of you guys have already finished number 3. If you've already finished number 3, you can do any of the rest of them, 4, 5, and 6. Hey, do you guys have any questions about these 2 adding up to 180? You can see that that's the straight angle. So now we can just use substitution. Okay, so if I plug in 7x plus 20 and 10 plus 5x, I'm going to go ahead and solve that for x. So I'm going to give you some time to do that now, okay, to solve that for x. If you're already done, then I want you working on 4, 5, and 6. And then remember, it is asking you to find the angles, so once you have x, you do have to plug that back in. Okay, take another minute if you're still working on 3, but again, go on to 4, 5, and 6, because whatever you don't finish for 4, 5, and 6 will be part of your homework, so if you can get it done now, that would be great. right, so the first part of this we can do in our heads because we have 7 and 5, which is going to add to 12, 20 and 10, which adds to 30. I have to subtract 30 from both sides, and then once we get here is probably when you're going to want to make sure you have your calculator. So when you divide by 12, you will get x equals 12.5. So remember, it's asking you to find the measure of LMO, and if LMO is 7x plus 20, you can just go ahead and substitute in the value that you found for x. So 7 times 12.5 plus 20, you can use your calculator for that. You should get 107.5 degrees. Okay, how did that go? Finding your angle measure. Good? All right, now for this second one, you have a choice. And if you were doing this on a test or a quiz, I would actually just double check both methods. So you can use substitution. For OMN, it would be 10 plus 5 multiplied by x, and you'd get 72.5. But we also know that together they're going to be 180. So if you just did 180 minus 107.5 to get the 72.5, that's perfectly fine. You do want to double check that those both add up to 180. The reason why I said on a test or quiz that I would do both is if you make a calculation error here and then just subtract, both of those answers would be incorrect. Okay, whereas if you double checked with substitution, then you might find your mistake. All right, so on that page, 4, 5, and 6 are going to be ones that you will do for homework. And the next angle we are going to go to are the complementary angles. And I'm sure you guys have already heard of complementary angles before. Some of us probably just need like a little refresher. So complementary angles are just a pair of angles that add up to 90. So a pair of angles that add up degrees. And the illustration I gave you is a pair that is also adjacent, but they do not have to be adjacent. So a pair of angles that add up to 90. So once you get that done, I want you to go ahead and start working on your practice problems. And I'm going to come around and check in with some of you. Okay, so for number 1, when you're trying to figure out the missing angle, if you don't have a calculator, what you should start doing is trying to add up to the number that you want. So I always try to go to a whole number. So the next whole number after 28 is 30. So how much would I add to get to 30? 2, and then from 30 to 90? 60, right? So then that's how you would get 62. Okay, you could also do the old-fashioned subtraction. Now, when you're naming a pair of complementary angles, this one is a little tricky. You have to remember a few things we talked about last week. So remember we talked about you can't just assume that it's a right angle because it looks like one. What does there have to be for a right angle? Yep, Andrew?
Square.
Yes, there has to be that little square. How many squares do I have in that diagram?
One.
Just one. So there's only one pair of angles that's possible for this. So you're looking for the 2 angles that are going to make this pink square here. Okay, so the 2 angles would be BFC and CFD. Okay, so no other possibilities. You could have that backwards though. You could have CFB and you could have DFC. Okay, and again, that's because that is the angle that has the box on it. Okay, some of you guys were hesitating to set up your stuff for number 3. Okay, we got to be able to read through those and then at least attempt setting up our equation. So one thing that can help is if you're just highlighting some of the important information, like what we have to find. So we have to find the measures of 2 complementary angles, A and B, when we're given expressions for each of those angles. Well, we know if they're complementary. Ryan, what do complementary angles do?
They add up to 90 degrees.
They add up to 90. So all I have to do is add these 2 expressions together and set them equal to 90. Okay, so from there, I can just go ahead and I can find my like terms and then solve for x. Yep.
Why is there like the little degrees thing behind the 7x plus 4?
That's to show that it's that whole quantity. So the whole angle is the 7x plus 4.
Oh, okay, yeah, because that's what threw me off, and that's why I like didn't do it.
Oh, okay. Yeah,
I didn't
so
get that right.
it's just if there's more than one term, they'll have that in parentheses. And then once we have that equation, it just turns into an algebra problem. So we have to get our like terms together. So I have 7x's here, I have 4 here, so together it makes 11. 4 plus 9 is going to be 13. So I'm going to subtract 13 from both sides. Again, if you're doing that without a calculator, I subtract 10 first and then I subtract 3. Because 90 minus 10 is 80. 80 minus 3 is 77. So then when I get here and I divide by 11, that's something else I can do in my head. So 77 divided by 11 is 7. Now make sure that you know what they're asking. So they're asking you to find the angle measures. So we can't just stop once we find x. We are going to plug those back in. And then just like we did on the other one, whichever one you find first, the second one you're going to have the choice of doing another substitution, or you could just subtract from 90. When you're doing your quiz or your test, make sure if you're finding complementary angles that they do add up to the correct value. So in this case, the correct value is 90. Okay, and then number 4 is something that you are going to finish for homework, if you haven't already. I know some of you are cruising, which is great. Okay, after complementary angles, we are going to talk about supplementary angles. So complementary angles equal 90, supplementary angles equal 180. And if you find yourself like confused on which is which, I always think about alphabetical order. So in the alphabet, C comes before S, so C is lower than S. Complementary is lower than the supplementary. Okay, so we are going to go to the supplementary part. And then again, once you guys have down your definition, you can start working on your examples. those you're already going to know how to do. And then that way, if you are pretty quick at going through, you can get some of your homework stuff done.
Yeah, they want to cross from each other. 3 and 4, 1 and 2.
Yeah, the ones that are across from each other. Then you know what their relationship is.
They're equal to each other.
So if you wanna go in, you wanna go that in here. Okay, so supplementary angles are a pair of angles whose sum is 180. The illustration I drew is also what besides supplementary angles?
So,
What other type of pair? Our illustration is also
linear.
linear pair, yeah. Good. They're a linear pair. Notice for number 2 it says name 2 pairs. So really you're going to have 4 angles there. So you'll have 2 pairs.
Jesus.
If you have 2 pairs of shoes, you have 4 shoes. Together. These are a little bit harder if you try them.
Okay.
No, these are words. The sheet I gave you is something that we're going to do together. Because some of those are a little bit harder. Alright, so I'm really confident in number 1 that you guys subtracted to find that that was 48. Do you guys have any questions for me on number 1? The supplementary? Okay, now the 2 pairs of supplementary angles. What you should be thinking about when you're naming them, and sometimes it even helps if like you mark them off, but you're looking for something that's right next to each other. So if they're supplementary and they're make up a straight line, you know that they're going to equal 180 degrees. So one pair that you could have was DEG. And then think about what angles are next to DEG. There's two of them. You could also have GEH. So DEG and GEH would be a pair of supplementary angles. I just went right around counterclockwise. So you could also have GEH and HEF. Okay, you could have HEF and FED. Notice that when I'm going on those lines, do I even have to pick my finger up and jump over anything? No, because they're right next to each other. And then your FED and DEG is going to be your last pair. Now, the order doesn't matter if it's forwards or backwards. So if you had GED and HEG, that's fine. If you had HEG and FEH, that's fine too. Okay, the middle does have to be the vertex, and the vertex for every single one is E. So E should be in the middle for every single one that you named. Okay? All right, then we got here, and it says find the measure of two supplementary angles A and B when you are given A and B. So the setup for this number 3 is just like the last one, except instead of setting them equal to 90, like we did for the complements, we're going to set them equal to 180. How did we do at setting up that equation? All right, so then when you add your 3x and your 2x together, you'll get 5x. Negative 7 plus 2 is negative 5. So then we're going to add 5 to both sides. When we divide each side by 5, we will get 37. Now it says to find the measure of the angles, so I'm going to use substitution to find the first angle, 104. So I found the measure of A first, which means I can just subtract from 180 to find B. And if I want to double check, I can use substitution. Okay, and then number 4 is going to be a homework problem. And then we're going to go to vertical angles. Did you guys do some things with vertical angles last year? In algebra? Maybe you did, but you don't remember it. Maybe you never did, and that's why you don't remember it. I did a little bit.
What was it?
In 8th grade. I know in 8th grade sometimes they weave some of it in because it's in your assessment. And then vertical angles is the second to last flat. And vertical angles are two non-adjacent angles. So these are the ones that are not next to each other. So for the vertical angles, there are two non-adjacent angles, and they are formed by two intersecting lines. So automatically, when you have those two intersecting lines, you have two pairs of vertical angles that are formed. So you have 1 and 2, and you have 3 and 4. And I wrote this at the bottom. I'm just going to write it at the top too. The relationship is that vertical angles are congruent. So that's important. Okay, vertical angles are congruent, which means that they are equal to each other. Okay, so go ahead and do what you can at the vertical angles. At the very least, do 1 and 2. To help you with number 3, you have to know that the vertical angles are congruent. And if you do finish all those early, remember the ones that we skipped, you can always go back and do those so that you have them done. what with the vertical angles? If they're congruent.
Make them the same.
How do we do it? How are we gonna do that with these?
Plug and chug.
Because our other ones, they weren't the same, right? They were supplementary, so then we added them together and set them equal to 180. If they're congruent, what do? Set them equal to each other, right? Okay, so this one's a little bit different. We aren't gonna add them together, we're gonna set them equal to each other. Alright, so let's check in 1 and 2, and then I can help you guys with your setup for 3 as well. Alright, so for number 1, name the 2 pairs of vertical angles. They were actually the same as in your drawing, so 1 and 2, 3 and 4. For name the angle that's vertical, bless you, with VZY. Cass, will you tell me what that is?
XZW.
Good. Okay, and again, you can call that XCW or WZX. See how I mark those off in my diagram too? Because they're vertical, which means they're the same. So when I get to number 3, and they tell me that those are going to intersect those 2 lines, and I have to find the value of x, the first thing I did was I just marked those congruent. So if they're congruent, then I have to set them equal to each other. So I'm going to set the 7 plus 13x equal to negative 20 plus 16x. And it doesn't matter what side each one is on. If you did negative 20 plus 16x equals 7 plus 13x, that's fine too. So now we just have to get all of our x's to one side. So I like to keep my x's positive, so I subtracted 13 from 16 to get 3x. And then I added 20 to get 27, which means my value of x was 9. This one only asked me to find the value of x, so I was good to go with that. Okay, and then like I said, I did put at the bottom that vertical angles are congruent. Okay, number 4, I'm going to save that for homework, but we are going to make sure that we can set up number 5 together. So for number 5, it says find the value of x and each angle if you're given the measure of SOP and ROQ. So the first thing I did is I just labeled my diagram. Now in our nice foldable, these are all organized by, oh, this is a vertical angle. So we know what we should do here. When you get problems and they're not telling you, oh, these have to be vertical angles, you're going to have to know when do you add them together and set them equal to a value, and when do you set them equal to each other. So it's really helpful to mark off in your diagram if they're congruent or not, and then you could set your 5x equal to 4x plus 10. Okay, so if we're getting all of our x's on one side, we can subtract 4x from one side, which just leaves us with x equals 10. So then you can substitute to find the measure of SOP. And if those 2 angles are congruent, because I know my vertical angles are congruent, I already know that ROQ is 50. So I don't even necessarily have to plug it back in. It's a good thing to mentally check that they are the same. So if I plugged in 10, I'd have 40 plus 10, which is 50, so I'm good. Okay, and if you're all done with 5, go ahead and try 6. 6 is another one for homework, so if you want to work on 4 and 6, if you haven't already, you can.
Are we doing this?
And then you can choose, so you are doing some of those for homework. If you want to wait till after you do them for homework and then glue it in, you can. Or if you want to glue that in right now, you can, or if you want to glue that in now, you can do that as well. And then we're going to go to your extra practice page, and we are going to start doing that together. So I want you to look at that extra practice page and see if you can read through the directions for the first one. We're actually going to look at 6. I really should have just had you do number 5. I forgot that I wanted to do that one with you. Okay, so for number 6, you're finding the missing angles. And the first thing that I would do is and you don't have to find your angles in order. So I would just start finding relationships. So right away I see that I have 72 degrees, and that is going to be a vertical angle with angle 1. So I already know the measure of angle 1 has to be 72 degrees because they're vertical angles. Okay, Grace, what other angle do I know because they're vertical angles?
3 is 41 degrees.
Good. Okay, so the measure of angle 3 is 41 degrees. Now I have to start using my patterns. Can anybody tell me a way I can find another one? Yeah, Andrew, go ahead.
Add 2 of them up. Like, let's say like you add 2. Yeah, you just have to add 2 of them up that are like next to each other,
Okay.
and then subtract that by, and then add those up, and then subtract it by 180 to get the missing one.
And why 180?
Because it's over like, I don't know, but it's over 180 because it's half the square, and once you get one of them, then you're able to put it on the other side too.
So can you guys see that these 3 angles together make a straight line? Okay, so if they make a straight line, that means that 72 plus 41 plus the measure of angle 2 is going to equal 180 because it's a straight angle. So then that means if I do 180 minus 72 minus 41, I'm going to be able to find that missing angle. And then you can use that to find the other missing angle. Okay? So the rest I'll just have you do, okay? I just wanted you to know that you could add those up. Okay, so now on our extra example sheet, it says that we have to tell whether the angles are only adjacent and form a linear pair, or not adjacent. So the first 2 we're going to look at are 5 and 6. Okay, so here's angle 5, here's angle 6. Are those 2 angles next to each other? Yep, and they share a common side, so are they adjacent? Yep. So then you can abbreviate adjacent as ADJ. Are they also a linear pair? Do they make a straight line? 5 and 6? Sometimes it's helpful to mark them off. Are those going to make a straight line together? Yeah, can't you see that they're going to form that straight line there? So they are a linear pair. So it's adjacent and a linear pair. The next 2 I'm going to look at are angle 7. So I have angle 7 here. Just going to draw an arrow. And then I also have SPU. So SPU, which is from here to here. Okay, are these angles adjacent? So remember, if they're adjacent, they can't do what? They can't overlap. And do these overlap? Yes, so this is not adjacent. Remember, in the definition of a linear pair, we talked about how they're also what kind of angles? A linear pair has to be what? Adjacent. So if it's not adjacent, can it be a linear pair? No. So then the last 2 we're going to look at are 7 and 8. So I have angle 7 here again, angle 8. Are those adjacent? So if you're unsure, ask, do they share a common side? Angle 7 and angle 8? What side do they share? QP and PT, those are not the same, right? That's an angle, right? Do they share a same side? No, the sides of this angle are PS and PT. The sides of this angle are PR and PQ. So they are not adjacent because they do not share a side. Okay, the next one, for the supplement, you have to think of this a little bit differently. So if we have an angle X, we call the supplement 180 minus X. So this is important. You'll have to write this down. Okay, so if we have two angles, one is X, the other one would be 180 minus X. That's just a general way that we can identify the supplement. So a problem like this is a little bit more difficult if you don't know that the supplement is 180 minus X. In this case, our X value is 2y plus 20. So our 180 minus X is 2y plus 20. Okay, I'll put the rest of this video up so that you guys can watch that, and you already have your homework written down, so you are good to go. Okay, so once you have your 180 minus your X value, you're going to distribute the negative. So it's minus 2y minus 20. And that's because you have to distribute. So you have to distribute the negative to both of those. So 180 minus 20 is going to be 160 minus 2y. And that's going to be your final answer. So it's 160 minus 2y degrees. Okay, and again, this comes from the fact that if you have an unknown angle and the supplement, if you know what x is, you can subtract that from 180 to find out what your other angle is. Okay, and then again, just remember that you're distributing. All right, for the next one, it says an angle's measure is 12 degrees more than half the measure of its supplement. We have to find the measure of the angle. So if we have any unknown, we're going to call that angle x. So an angle's measure, we're just going to call that x. If we know that the angle is x, if we know that that angle is x, then we just talked about above how the supplement would be 180 minus x. So now we're going to set up our equation. So it says an angle's measure is. Remember that the word is in math is an equal sign. So an angle's measure is would be x equals 12 degrees more than half the supplement. So half of the supplement would be 1/2 times 180 minus x. And then the 12 more is just going to be plus 12. And then what we would do is solve this for x. So we're going to distribute the 1/2. 1/2 of 180 is 90. And then the 1/2 x. And then when I combine my like terms, I will have negative 1/2 x, and 90 plus 12 would be 102. And then I'm going to get all my x's to one side. And then just remember that this is like a 1 here. So 1 plus 1/2 is 1 1/2, 1.5. So I'm going to divide both sides by 1.5, which will give me 68 degrees. And then this is something that you could also check. So an angle measures 12 more than half the measure of the supplement. If you have 180 minus 68, you can use that to find your supplement. So if you're doing this without a calculator, just add up. So I would add 2 to get to 70, and then 110 to get to 180. So 2 and 110 is 112. Okay, so this is going to be the supplement. So it's 12 more than half of that. So if I do half of 112, half of 100 is 50, half of 12 is 6. So that would be 56. And then if I do 12 more, that would be 68. All right. And then you can go ahead and cut this out, and then you can glue that into your interactive notebook.